Welcome to this session. This session introduced the concept of integration of rational functions by partial fractions. So our aim here is to show how to express rational function these are quotient of polynomials as a sum of simpler fractions called partial fractions which may be easily integrated. So that's the main aim. For instance, the rational function f of x given by 5x minus 3 over x squared minus 2x minus 3 can be written as five x minus 3 over x squared minus 2x minus 3 is given by 2 over x plus 1 plus 3 over x minus 3. That's how we can write that rational function. So thus, the integral of f of x, remember this is f of x, dx, which is the same as integral of 5x minus 3 over x squared minus 2x minus 3 dx is the same as the integral of 2x plus 1 plus 3 over x minus 3 dx, which is the same as integral of 2x plus 1 dx plus integral of 3 over x minus 3 dx. This is 2 integral dx over x plus 1 plus 3 integral of dx over x minus 3. Then for this a and this one b, so if we let u to be x plus 1, then du is dx. And for this other part, if we let u to be x minus 3, then du is dx, so that this integral will be 2 integral du over u plus 3 integral du over u. Let me call this one u1, 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 u1. And then this will give us 2 ln of u plus 3 ln of u1, then plus c, which will be just 2 ln of x plus 1 plus 3 ln of x minus 3 plus c. So it becomes, it makes the integration process much easier than when the rational function has not been broken into partial fractions. So the interest will be to show how to express, or the question here, how did 5x minus 3 over x squared minus 2x minus 3 become 2 over x plus 1 plus 3 over x minus 3, i.e., how do you express, how did this 5x minus 3 over x squared minus 2x minus 3, how was it possible to express it in the form a over x plus 1 plus b over x minus 3? So this will be the questions that we'll be trying to answer in this given chapter. So let's give the steps on how to behave whenever you are given rational functions which may require you to decompose into partial fractions. So general description of the method, so one thing that you have, what you have to remember is that success in writing a rational function f of x over g of x as a sum of partial fractions depends on two things. The first one, the degree of the numerator, that is f of x, the degree of the numerator must be less than, strictly less than, must be less than the degree of g of x. This is to say, i.e., the fraction must be proper. So in terms of functions, fraction f over g will be proper if and only if the degree of f of x is strictly less than the degree of the denominator, g of x. If this is not the case, that the degree of the numerator is strictly less than, not less than or equal to, but strictly less than, if it isn't the case, then divide f of x by g of x and work with the remainder. That is always the first thing that you must ensure. And then number two, second thing that you must consider, we must know the factors of g of x. That means that if g of x is not given in terms of factor, then you have to factorize that polynomial g of x. So those are the two things that this process requires to be considered before you start any process. Now, method of partial fractions. Assuming that now we have seen that all those two processes are satisfied, let's see how you work out method of partial fractions. When f of x over g of x is proper. So let's quickly discuss through the tricks. One, let x minus r be a linear factor of the denominator g of x. Suppose that x minus r raised power n raised power m is the highest power of x minus r that divides g of x then to this factor assign the sum of the m partial fractions. They are a1 over x minus r plus a2 up to plus am x minus r raised power m. Do this for each distinct linear factor of g of x. So that's the first trick we consider. Another one, let x squared plus px plus q be an irreducible quadratic factor of g of x so that q squared plus px plus q has no real roots. Suppose x squared plus px plus q raised power n is the highest power of this factor that divides g of x then to this factor assign the sum of n partial fractions so denoted by b1x plus c1 over x squared plus px plus q plus b2 x plus c2 over x squared plus px plus q squared up to plus bn x plus cn over x squared plus px plus q over n. Number 3, set the original fraction. This number 3, f of x over g of x equal to the sum of all these partial fractions and then clear the resulting equation of fractions and arrange the terms in decreasing powers of x. And then lastly, number 4, equate the coefficients of the corresponding powers of x and solve the resulting equations for the coefficients. So that is the process that we follow. In the next session, we give examples on how to integrate by partial fractions. Thank you.